Hello everyone, welcome back to the channel, and today I have another topic in calculus, and we are going to look at the sign of f prime x for a real valued function f defined from a domain of real numbers to a codomain of real numbers, where I am saying that f prime of x is basically the first derivative of fx. Standard notation, and we know that, but what can we conclude from the signs of f prime x? So we can say that for a constant c, where c belongs to a real number, so of course f of c is defined. So we can say that the function is increasing at c if f prime of x evaluated at x equal to xc is greater than 0. And when can we say that the function is decreasing at c? Like, I don't need to keep writing fc, because we are looking at the sign of the derivative, not the sign of the original function. Yeah, but the function is increasing or decreasing, not the derivative. We are just looking at the sign of it. But since the derivative is the slope of the function at this point c, so this is c. The sign of the derivative reveals some information about the original function. So if this is less than 0, we can say that the function is decreasing at c, and if this is exactly 0, then we can say that the function is stationary at c, or in other words, c is a root of f prime of x, sometimes also called a 0 of f prime of x, because f prime of x vanishes at c. But all of these definitions are for one constant c belonging to a set of real numbers. What if I have a range, I have an interval for f of x, because both boundaries in that interval belong to real numbers, and f is defined everywhere, so f of a and f of b are obviously defined. These are defined, and hence I'm now interested in looking at the signs of f prime x in this interval. So we're going to say that if f prime of x is greater than 0 for all x belonging to this interval, so this is for all, so for all values of x in this interval a and b, including a and b, if f prime of x is greater than 0, then we say that f prime of x is strictly increasing in this interval. And if it's the other way around, if f prime of x is less than 0 for all x belonging to a and b again, then we are going to say fx is strictly decreasing in this interval ab. And there's another name for it. This is called a monotonic function. It's called monotonically increasing, and this is also a monotonic function, but it is monotonically decreasing in this interval. It could be anything outside the interval, I don't know. If I have to know what it is outside the interval, I would need to know the signs of f prime x in whatever that interval is. And now if I have to talk about stationary points in an interval a and b, I have defined stationary point at one point where it is 0. So yeah, if f prime of x is identically 0, you can say that there are infinite stationary points, but that doesn't really help much. Practically what you would get is, I want to find this c, a c such that f prime x needs to be 0, so that I can say that c is a stationary point. But for an interval, I'm going to say that fx has a stationary point in this interval if there exists. This sign means there exists there exists at least one C where C belongs to this interval AB such that at C f prime x is 0, and hence C is a point of stationarity, and I can say that there is, f of x has at least one point of stationarity in this interval. There could be more, but this says there's at least one C. So if we have something like this information available, we can conclude this. These properties are going to be really useful when we try to solve problems, especially when we model piecewise functions in calculus. So thank you so much for watching this video, and thanks for always being here. Thank you.